Hello, in this video, we're going to look at the second half of lesson 5.8, applying special right triangles. If you haven't already completed the notes for 5.8 day 1 or watched that video, you should go back and do that first. In this video, we're going to do kind of a mixed review of what we did in day 1, where we're going to be using properties of special right triangles to solve problems involving 45, 45, 90 triangles and 30, 60, 90 triangles. Before we jump into the problems, let's just review our formulas. In a 45, 45, 90 triangle, the two sides that are opposite the 45-degree angles are called the legs. And because both angles are 45, the legs are going to be congruent. So both legs are the same. And then the hypotenuse, which is always across from the 90, is just the leg times the square root of 2. So I usually write it as hypotenuse equals leg root 2. And that's the relationship for a 45, 45, 90 triangle. When we have a 30, 60, 90 triangle, there is a short leg, which is going to be opposite the 30-degree angle. So in our picture, the short leg is the B. The long leg is opposite the 60-degree angle. And again, the hypotenuse is always directly across from the 90-degree angle. Well, the long leg is going to be the short leg times the square root of 3. So I usually write it as long equals short root 3. And then the hypotenuse is twice the short leg. So hypotenuse equals 2 times short. So make sure you have those formulas written down in your note packet. And then when we start our problems today, we're first going to look and see which type of triangle is it. Because depending on what the triangle is, that's going to help me determine which relationship I should use. All right, so find the length of the missing variables. We'll leave our answers in simplest radical form. This first triangle here has a 60-degree angle in it, so we know that it must be a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, the hypotenuse is across from the 90, as always. Short leg is opposite the 30 angle, so here the short leg is 2 root 2, and the long leg is opposite the 60-degree angle. Since we know the short leg, we can use the short leg to figure out the hypotenuse and the long leg. Let's start with the hypotenuse. In a 30, 60, 90 triangle, the hypotenuse is 2 times the short leg. So here, the x, the hypotenuse, is just going to be 2 times 2 root 2. And since 2 and 2 are not in the root, they can combine together, keep root 2 the same. There's no other roots to multiply it with. 2 times 2 is 4, so we'll say x is 4 root 2. And now let's go ahead and find the long leg. The long leg is just the short one times root 3. So if we sub in our values, we have the long leg, the y, equal to the short leg, 2 root 2, times the square root of 3. This time, notice that we have two radicals, and a root 2 times a root 3, since these are both under the root, we can combine them to be root 6. 2 times 3 is 6. That 2 has nothing to multiply with it, so I'm going to keep it as just 2 root 6. For problem B, we are switching now to a 45, 45, 90 triangle. So in a 45, 45, 90 triangle, you still have your hypotenuse across from the 90, but both legs are the same. There's no long leg and short leg. They're just the same value. So right away, without doing any calculating, since the legs are congruent in a 45, 45, 90, we know that y must be equal to 3 root 2. Both legs are the same. Now we need to find the hypotenuse, and in a 45, 45, 90, the hypotenuse is the leg times the square root of 2. So here x is going to be 3 root 2 times root 2. And recall here that a root 2 times a root 2 is root 4. But square root of 4 is a perfect square. That's just 2. So I actually have x equals 3 times 2. A root times itself. Remember, the root just goes away. Root 2 times root 2 is just 2. And 3 times 2 is 6. So the hypotenuse, x, is equal to 6. You could also type 3 root 2 times root 2 into your calculator, and it would give you the 6. Moving over to triangle in C, we have another 45, 45, 90. This time, the hypotenuse is 6 root 2, and we don't know the legs, but we do know that they're going to be the same. So since I know the hypotenuse, I have to use the formula for the hypotenuse, which is the leg times root 2. Well, here, the 6 root 2 then, the hypotenuse, will be the leg. You can pick either x or y. I'll just do x, root 2. And we need to get the x by itself. So let's go ahead and divide each side by root 2. And since there's a square root of 2 on both sides, that cancels, and now x is just 6. And then the other leg is the same, so y is also 6. The hypotenuse, 6 times root 2, leg root 2, so that makes sense. Here's a few more examples. In problem D here, we have another special triangle, and this one we're back to a 30, 60, 90. So I'm going to label my hypotenuse first, across from the 90, and then the short leg is directly opposite the 30-degree angle, and the long leg is across from the 60-degree angle. So since we have the long leg, we need to start there. So look at your theorem for your 30, 60, 90 triangles, and you'll see that the long leg is the short one times the square root of 3. So here the long leg, which we know is 2, is equal to the short leg, y, times the square root of 3. Well, we need to get rid of that multiply by the square root of 3, and we can do that by dividing each side by root 3. And when we do that, we're going to get just y equals 2 divided by the square root of 3. Now, to finish it up, let's go ahead and calculate the hypotenuse. The hypotenuse in a 30, 60, 90 triangle is equal to the leg, the short leg times 2. So we know the short leg is that 2 divided by 2 root 3. And when we multiply those together, 2 times 2 in the numerator would become 4. And then the denominator is going to stay as root 3. So we'll have 4 over root 3 for our x value. Problem E here, we're back to a 45, 45, 90. Hypotenuse is 11, and then the legs are both x and y. So we have to make sure that we always look and see what type of triangle do we have, because the type of triangle that we have determines which formula we use. We have the hypotenuse, we have a 45, 45, 90. So if we look at our theorems for 45, 45, 90 triangles, the hypotenuse is just the leg times the square root of 2. So here, 11 is going to be equal to the leg. I'll go x, root 2. And we need to now solve for x. So I'm going to clear that root 2 by dividing each side by root 2. And that gives us x equals 11 over root 2. Now we know the legs are the same. So that means the y will also be 11 divided by the square root of 2. All right, and for our final example here, we are back to a 30, 60, 90 triangle. And notice that the 22 there is directly across from the 90. So that is my hypotenuse. And then we have the long leg across from the 60 and the short leg across from the 30-degree angle. Since we know the hypotenuse, we have to start with that equation. In a 30, 60, 90 triangle, the hypotenuse is 2 times the short. So I have to make sure I'm using the right formula. On the problem before it, I used hypotenuse equals leg root 2 because we had a 45, 45, 90. In a 30, 60, 90 triangle, we have to use the hypotenuse is twice the short leg. So here, the 22 is going to be the short leg times 2, so that's 2 times y. And if we divide by 2, that is 11. So our short leg is 11. 22 divided by 2. And now that we have the short leg, we can calculate the long one. The long leg is just the short leg times the square root of 3. So since we know the short leg is 11, that means x is just going to be 11 times the square root of 3, or 11 radical 3. So that concludes our video. Thanks for watching, and good luck as you practice your special right triangles. Bye.